if the derivative gives us the what does the derivative give us? The derivative, the point of a derivative is to give us the overall, the slope of the tangent line, okay? What does the antiderivative give us, okay? And the derivative could give us the slope of the tangent line at an instantaneous point. That is the overall goal. An antiderivative, the goal is to give us the area under the curve. Okay, so derivatives, slopes, antiderivative, area. Okay, so let's talk about that a little bit more today. Okay, so let's think about that very first function that we looked at when we first started this whole unit over area approximations. Okay, what were the 4 different ways that we could do approximations? We had left hand, we had right hand, we had midpoint, and we had the trapezoidal method. Okay, I'm not going to go through all those individually, but this was all of our approximations. Then, to get it to be exact, we took the limit, and we had the limit definition of area. Okay, we also, to find area exactly, not necessarily for this particular problem, but in some cases, we could use geometric approach if we had a nice pretty shape that we knew how to work with. Okay, so that was how we found the area. Now let's talk about a couple things. We've also talked about 2 different types of integrals over the past few days. We've talked about an indefinite integral versus a definite integral. If I were to take the indefinite integral of this function, that means the integral of 5 minus x squared with respect to x. Basically what I would do is I would notice there are no bounds here. That's what makes this an indefinite integral. And I actually want to move that down so I can label that. Okay, this is my indefinite integral. The result here, so if I go ahead and I do the indefinite integral here, the antiderivative of 5 is 5x. The antiderivative of negative x squared is negative x cubed over 3. Then I always put plus c. My overall result here is what we call the general solution. Okay, the general solution would help me find the actual function that would fit a particular situation if I was given a specific value on the function in question. Okay, now what we could also do, and what we did in the past, is we did a definite integral. It's been a little while since we did this. When we did the indefinite integrals in the past, for example, for this function, we wanted the area from 0 to 2. Okay, so if I did the definite integral from 0 to 2 of 5 minus x squared dx. Okay. What that will actually do is that will also give us the area, the exact area under the curve. So when we did that before, that we used our limit definition to rewrite our definite integral as a limit, and then using summation properties, we found the area. Okay, well now today what we're going to do is we're going to combine these 2 concepts together. Because do you see how closely related these 2 look? You've got no bounds versus bounds. This is telling me I don't know where I want to find the area. I just want to find it in general. What would be my pattern? Okay, well now I know specifically that I want to go from 0 to 2. So here's how this works. We know how to solve for the integral of 5 minus x squared. You already did that here. So the antiderivative of 5 is 5x. The antiderivative of x squared is x cubed over 3. Now we have to account for the fact that we have these bounds in here. So what we do is we draw this line right here, and I say a 0 to 2. This is my lower bound. This is my upper bound for my area. Okay? So what happens next, okay, is I plug in this number right here into the top, or into both places where I have an x. So I'm going to have 5 times 2 minus 2 cubed over 3. Then I'm going to say minus, plug in 0. 5 times 0 minus 0 cubed over 3. Okay, then I end up with 10 minus 8/3 minus 0, because all that just becomes a 0. Well, that equates to, let's see, 22 over 3. And if you recall, that is the exact same thing that we got when we found the area using the limit definition. Okay, so the goal of today is to try to bring all of these things together. You start out with approximations, then you find them exactly, you find area exactly using the limit definition. Okay, well then, you know, sometimes this becomes really tedious. Well, someone discovered that when you take the antiderivative, that works out to be the exact same thing as using the limit definition of your area. It works out every single time that way. So the result of a definite integral is the same thing as the limit definition of your area. It's the exact same thing. So now, unless they specifically tell you to use the limit definition, if I tell you to evaluate an integral and I give you bounds, I just want you to do it using this method right here. Isn't that amazing and so much faster? Ah, you are welcome. You are welcome. Okay, so let's try another one. Okay. The function is from 0 to 4 of the square root of x with respect to x. Okay, again, if I wanted to, this is a definite integral, I could write this as a limit. I really don't want to. Do you want to? I mean, if you do, go for it, knock yourself out. But I'm going to do this the faster way so that way we can get this done a whole lot quicker. The first thing I'm going to do is say from 0 to 4, x to the 1/2 dx. And then I will do the antiderivative. So this becomes x to the 3/2 over 3/2 from 0 to 4. That is a 0, not a 6, but it looks a little confusing, so I will do that. This becomes 2/3 x to the 3/2 from 0 to 4. And just like on the last problem, I'm going to plug in the 4 first. 2/3 times 4 to the 3/2 minus 2/3 times 0 to the 3/2. And you end up with 2/3. Let's see, square root of 4 is 2, cubed is 8, minus 0. End up with 16/3. Again, if I wanted to do this using the limit process, you would get the exact same thing. Okay. Some people might ask the question, Murphin, hey, if I plug in a 0 and I know I'm going to get 0, do I have to show the work? What do you think the answer to that question is? Yes, you must show this. Okay. Must show that step right there. Okay. I'm going to erase that because that'll look confusing whenever you guys look at these notes on Canvas later, assuming you actually do that. I don't know. I always hope that you do, but you know, maybe you do, maybe you don't. I don't know. Okay. Well, what if we had something like this? From 1 to 3, I want negative x squared plus 4x minus 3 with the area under the curve of this function from 1 to 3. Well, let's give it a shot. The last two were functions we already knew and that we'd already seen before. Let's try something new, shall we? All right. Oh, helps if I'm not using the eraser. There we go. So the antiderivative of negative x squared is negative x cubed over 3 plus 4 times x squared over 2 minus 3x. Oh, wait a minute. Oh, that was silly. That was so silly. You take that away as soon as you start to integrate. Okay? When you go from this step to this step, this goes away and that goes away. Okay? I just did that on accident. So, no, go away. All right. But I'm evaluating this from 1 to 3. So, I'm going to say, plug in a 3, and I've got negative 3 cubed over 3. 4. Actually, this works out to just be 2x squared. So I'm going to go ahead and just make that 3 squared minus 3 times 3 minus, since I have some negatives here that need to make sure that I distribute this negative to, I'm going to plug in the 1 with my bracket here, 1 cubed over 3 plus 2 times 1 squared minus 3 times 1. Okay. And I'm going to end up with, let's see, 27 and 3 is 9, so negative 9 plus 18 minus 9 minus -1/3 plus 2 minus 3. So then we've got negative, those are going to all cancel each other out. That's a 0 minus, and then let's see, 2 minus 3 is a -1, and a -1/3 makes it -4/3, but so all in all, +4/3 is the area under the curve of -x² plus 4x minus 3 between points 1 and 3. Ta-da! Okay, so let's see what are we doing here? So this whole thing is my antiderivative, correct? But this is my antiderivative evaluated here. This is my antiderivative evaluated here. So essentially, when I have an integral from a to b of f of x dx, I'm finding the antiderivative at b, and I'm subtracting the antiderivative at a. This is what we like to call the first, that got a little bit messed up, the first fundamental theorem of calculus. Actually, it's called the fundamental theorem. It's the first one. There's actually going to be a second one, but we call this the fundamental theorem of calculus. If a function is continuous on the closed interval from a to b, and f is an antiderivative, a capital F is an antiderivative f on the interval from a to b, then the integral from a to b of f of x dx is equal to the antiderivative evaluated at b minus the antiderivative evaluated at a. How curious is that? And how nice is that we don't have to find the limit definition every single time? Oh my gosh, it's such a time saver. So this is a very, very common theorem that's going to come up a lot. We actually will rearrange it a lot as well. A very common rearrangement that we will do is we'll isolate this guy right here. So a lot of times you might see this. If I wanted to isolate this, I would just add this guy over. So a lot of times you're going to see this use of the equation, f of a plus the integral from a to b of f of x dx. You might just want to write that down. This is a useful rearrangement to use later. Okay? There you go. All right, just keep that in your back pocket. Keep it handy. So, let's do some more practice problems. This is a great opportunity for you to pause the video, check your work, get it done, and then come back and see if you got the same thing. I am actually not going to work through all of these in the video. I'll work out that last one, secant squared, but the other two, I'm going to just go ahead and work these out real quick, and then you'll have the answers here in just 1 second. Okay, I had to do a little bit of rearranging real quick to make sure I had enough room, but the first two answers are -2/3 and 14. I'll go ahead and do this last one because it is a trig one, and sometimes we get a little bit trigged up on our trig problems. I crack myself up sometimes. Oh my gosh, I'm so funny. Okay, the antiderivative of secant squared we know is tangent of x from 0 to pi over 4. So we're going to say the tangent of pi over 4 minus the tangent of 0. The tangent of pi over 4 is 1 minus tangent of 0 is 0, and you get 1 over all. Okay, not that tricky, but I just wanted to go ahead and show you that last one just in case you got trigged up. See, I did it again. Okay, moving on. Oh no, real world problem. Here's your scenario. Before a major motion picture is first released to the masses, there is usually a small number of theaters showing the film to test the waters. After a week or so, the movie is widely released with the hopes that the movie earns millions of dollars to not only cover the cost of production and advertising, but so that the movie company can make a lot of money to keep making more money. I mean, more movies. Below is the function that roughly approximates the amount of money earned on a specific movie on a given weekend over the course of 6 weeks in millions of dollars. Okay, so here's our function. Cool. Between weeks 1 and 4, what is the average amount of money that was being earned by this film? What is the average amount of money? Okay, So on the next slide, I've got this graph here of this function. So between weeks 1 and 4, I want to know what's the average amount of money that was being made at any given time. So this graph, basically what I did was I found different data points and I, used my, my regression tool on my calculator to come up with a good curve that would approximate this function based on those data points, okay? But what's happening here is up to week 1, like at week 1, they were making this much money. On week 2, they were making this much money. Week 3, 4, 5, and this kind of makes sense because a movie starts out, it's kind of okay. Like some people have seen it and they're like, oh, it's pretty good. And then they've told some friends and those friends have, their friends have seen it too. And so then, maybe it's a really good movie. So then it starts to kind of progress a little bit. They make a little bit more money each week. But then after a while, you only can make so much money because the movies can only stay in the theaters for so long. And so the amount of money that they start to make declines. So what they're asking for is what's the average amount that was made between weeks 1 and 4? Well, what's happening here, let's think about this. Normally when I want to find the average of something, I pick all of the values, like however many values I have. Like let's say there are 10 values. If I wanted to find the average of those, I add them all together and divide by 10. Super simple. But in this case, it's not quite as simple because let's think about how many y values are there between 1 and 4 on this curve. Because remember, this function is approximating the amount of money earned. So just on this curve, how many y values do I have from here to here? I can't even draw that. How many y values? There's an infinite number of them. Okay, that's the beauty of numbers, is that no matter, like between 1 and 2, there's an infinite number of numbers. Between 1 and 1.5, there's an infinite number of numbers. Okay, I have no way of finding the average just by adding up each individual term because there's an infinite number of them. So somewhere in here, though, if I could find that number somewhere, maybe like right here, this number is the average value of my function. So I'll call that f of c. And I don't know what c is. C is maybe like, down here. Average value of, actually, so this is this number is f of c here. Let me try to do. So this is f of c, average value of f of x over 1 to 4. I'm going to put that in a bracket because I'm including the 1 here. Okay, well, something that is unique about the average value is that if I were to use that average value to create a rectangle, the really cool thing is the average value of that function between 1 and 4, I could use that, like if I created this rectangle, the area of this rectangle is exactly the same as the area under the curve from 1 to 4. How crazy is that? Okay, so we know that to be true, but the question becomes, well, how do I determine what f of c is? Well, I know, so what I'm saying is the area of that rectangle, which that rectangle area of equals area under f of x from 1 to 4. Okay, so the area of a rectangle is base times height. Okay, so the base is the distance between 1 and 4. So length times width, and that's going to be equal to a to b f of x dx. We know we've done this now several times. Okay, all right. Well, the length was 4 minus 1. I know that it's 3 in my head. I can do that much math, but to show that it's like, the furthest one minus the closer. Yeah, you get what I'm saying. And then the height is going to be that f of c that we don't know what it is yet. is equal to the integral from 1 to 4 of f of x dx. Well, technically, we know how to do this thing right here. We've done this, okay? That's what we did all day today. We used the first fundamental theorem of calculus. You take the antiderivative of your function, you plug in the 4, and then you plug in the 1, and you subtract the 2. Okay, well then I also know how to do 4 minus 1. That's pretty basic. So really all I need to do is just divide that to the other side, and I'm left with f of c. So f of c is equal to the integral from 1 to 4 of f of x dx over 4 minus 1. Or in general, because we like to, follow a pattern here, a, b, f of x dx over b minus a. Oh my gosh. So even though I have an infinite number of terms right here, using the concept of area, I can still find the average value of all of the y values between 1 and 4. And in this case, the average value would be found by plugging this guy in right here. Okay, now that last equation was a little bit gross, so we're not going to actually find that yet. But you know what? If you want to, later on when you find out how to do this in a calculator, you're welcome to come back and figure that out. Because now I'm kind of curious, but I didn't think to work that out until just now, and we'll just do that later. Okay. So, average value theorem. If f is integrable on the closed interval from a to b, then the average value of f on ab is, you've already written this down, is 1 over b minus a times the integral from f of x, from a to b, f of x dx. Now, this looks slightly different. There are 3 ways to write this. This one looks closer to how I had written it a second ago. This is the exact same thing. It's just bringing this out in front as a constant multiple instead. They have the exact same meaning. Also remember, this right here is the same thing as the antiderivative evaluated at b minus the antiderivative evaluated at a. So then a third way of writing this is capital F of b minus capital F of a over b minus a. All of these are equal to the average value. Okay? You don't have to memorize all 3 of them. I would recommend that you can recognize all 3 of them because we will write these in a variety of ways, and you want to make sure that you know exactly what we're talking about. Okay? So if you need to pause the video and jot these down, go ahead. I'm going to go ahead and move on, and we're going to go to the next thing here. Okay, so I want to find the average value of my function f of x is equal to the square root of x from 0 to 4. So we already knew earlier that the area under the curve from 0 to 4 was 16/3. I believe that was what we found. But now I want to know what is the area under, what is the average value of all of those y values. So the average value, f of c, is equal to 1 over b minus a from a to b f of x dx. So 1 over 4 minus 0, the integral from 0 to 4 of root x dx. Well, since I already did this one earlier, I'm going to cheat a little bit. I already know that this is equal to 16/3. So then 1/4 of 16/3 is just 4/3. So even though on this curve from 0 to 4, 0 to 4, I have an indefinite, an infinite number of y values right here. The average y value out of all these y values is 4/3. That's pretty cool. Now, the question is find the value of c on this, on 0 to 4, such that f of c is the answer you found above. So find the value of c. So what x coordinate gives me that? Well, I know that this is my y value, so root x is equal to 4/3, so I just need to solve for x. So all I'm going to do is just square both sides and say x is equal to 16/9. So when I plug in 16/9 over here, which is like a little bit more than 1 point something, so that gives me a y value that is equal to the average of the entire curve from 0 to 4. I think that's pretty cool. Let's try another one. So find the average value of f of x equals 3x squared minus 2x on 1 to 4. I don't know that we've done that one yet today. So let's go ahead and work this one. So f of c is equal to 1 over 4 minus 1, b minus a, from a to b, a to b, 3x squared minus 2x dx. So f of c is equal to 1/3 from 1 to, no, I'm taking the antiderivative, so I don't need that. So I'm going to have 3x squared, so that's just x cubed minus x squared from 1 to 4. So notice how I didn't put like that big huge line that I normally put at the end of my antiderivative. Anytime you have a grouping that you are already putting around this with the 1/3, if you write it like this, it's understood that you've taken the antiderivative and you're evaluating it between these 2 points. Okay, so you don't have to have that separate line right here. Okay, you already have a grouping, and they know that it's not just to the 4th power because you have this extra 1 out here. So this is 1/3. And then I'm going to say 4 cubed minus 4 squared minus 1 cubed minus 1 squared. So 1/3 times 64 minus 16 minus 0. 64 times minus 16 is 48. 1/3 of that is 16. So the average value from 1 to 4 of that function is 16. Find the value of c on 1 to 4, so that's f of c is the answer you found above. Okay, so I want to know, where does 3x squared minus 2x, where does that equal 16? At what x value do I get 16? So 3x squared minus 2x minus 16. Oh no, it's everyone's favorite, it's factoring. Da, 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 da. Ah, love factoring. So that's going to be 3x and x equals 0. I need 2 numbers to multiply to 16, but then with that 3 out front, they're going to combine. Let's see. If I did 8 and 2, 3 times 2 is 6. 8 times 1 is 8, so then 8 and 6 will combine to a 2, but I need a negative, so that's got to be a negative. That's got to be a positive. So x equals 8/3 or negative 2. However, I'm only looking at the interval from 1 to 4, so only x equals 8/3 works in this situation, okay? Because that is the only one that is within the interval we need, okay? There is another way to ask this question. Find the value of k such that f of x is equal to the square root of x has an average value of 1 on the interval from 0 to k. So now we know what the average value is. So we know f of c is equal to 1. I need to find out, what is the value of k? All right, let's start with our equation. F of c from 1 over b minus a. Oh, that looks messy. Hang on. b minus a from a to b of f of x dx. I already know that this is 1 equals 1 over 0 is a. I don't know what b. K, so I have k minus 0 from 0 to k of root x dx. This is interesting. So 1 equals 1 over k. The antiderivative of x to the 1/2 is 2/3 x to the 3/2 from 0 to k. Remember, this is x to the 1/2, and then you add 1 and divide by, okay. So then I've got 1 equals 1 over k, 2/3 k to the 3/2 minus 2/3 times 0 to the 3/2. Oops. Let's see. That just becomes a 0. So 1 equals 1 over k times 2/3 k to the 3/2. I can reduce that here. 1 equals, this is essentially k to the first, so k to the 3/2 divided by k, that becomes 2/3 k to the 1/2, and then I multiply 3/2 equal to k to the 1/2, and then I square both sides and I get 9/4 is equal to k. So if I were to just look at the interval from 0 to 9/4, the average value would be 1. Cool. Okay, find the average value of sine of x. This is the same kind of concept, but just with sine and cosine. So I'm going to let you guys do this one on your own. I will post the answer to this on Canvas for you guys. And then let's see, what else we got here? Find the average velocity of the particle, and given its position is p of t. Okay, so find the average velocity given position. Ooh. Okay, so I have position, but I need average velocity. Let's go ahead and talk about this one. So for velocity, well, velocity is the derivative of position, which I do have that, but I don't have velocity. So I need to find p prime of t to give me v of t. So that's going to be 6t minus 4. Okay, and I want to find the average value of that from 0 to 9. So the average value of my velocity is 1 over 9 minus 0 from 0 to 9 of 6t minus 4 dt. Okay, so v of c is 1 over 9. Let's see, that's going to be 3t squared minus 4t from 0 to 9, right? Yep. It looks vaguely familiar, almost like it's right up above there. Interesting. We'll come back to that. 1/9, 3, nope, yeah, 3 times 9 squared minus 4 times 9 minus 3 times 0 squared minus 4 times 0. 1/9 is equal, oh, not equal to, 1/9 times, let's see, 81 times 3 is 243, and then minus 36 here, and then times 1/9, let's see, I have the final answer. 243 minus, what is that, 36 minus 0, 243 minus 36, 1/9 of, what is that, 207, right? Yeah, and that works out to be 23, whatever our units are, which we don't know. Okay, so my average velocity is 23. Now, that's using the average value theorem. I want us to think about this for a second. If I have a position function here, okay, I could find my position at 0. I could also find my position at 9, subtract the two, and that would give me, like over time, that would give me the same exact answer. Okay, so remember, another way to find average velocity is your position at the end minus the position at the beginning over your distance traveled. So 9. Okay, so initial position, like your ending position minus your initial over your total time traveled. That works out the exact same way. So P of 9, whatever that is, so, well, that was basically this plus 7, so 214 minus 7 over 9. Oh, that's also 23. Oh my gosh, I could have just done it that way. So even though we're asking for the average velocity, the reason I went over this question is because sometimes even though they're asking for the average velocity, you don't have to actually do the average value theorem. If you think about what you know about average velocity in terms of slope and position and all that good stuff, so you don't have to go through that whole long-winded process unless you just really want to for good practice, which, you know, by all means, go for it. Have a big time. That's the end of our notes for the day. I actually do have one more example, but I'm again going to post that on Canvas filled in for you already. So yeah, that is average value theorem along with the first fundamental theorem of calculus. These are two very, very big ideas that we talk about in calculus a lot. That's why we did these together, because basically one of average value theorem uses the first fundamental theorem inside of it. So if you have questions, Prof. Rob, Bob, Khan Academy, and your textbook, have a great day.